Hi students, in the last lecture we had an introduction to power generation, or in introduction to power engineering we started the subject, and now I think you have an idea about our power system network. Like, our power system network consists of the generation, transmission, distribution network, right? In which we will see one by one. So the first thing what we are going to see is what generation, and about that let us understand. Okay, and we have seen various things like what is meant by generation, transmission, distribution, what it is meant. Okay, and what is the need. These all things we have seen in the last lecture. So here we will particularly see about generation, but so in electric generation, what we do is that we will take one form of energy. It may be the potential energy of water in case of a hydel power plant, or we will take the thermal energy of the that we take from the coal and convert it into steam and use it, or it might be the nuclear fission or fusion reaction that we are going to use. Okay, or it can be the wind speed. So basically these all energy forms that we are converting it into electrical energy. That is what we meant by generation, or the electric power generation. So that is the process that we are going to discuss, and there are different types of this electric power generation. So let us see what are they. Like, one is the first thing what we are going to discuss is hydroelectric generation. In case of hydroelectric generation, as you know, that is the one main generation unit for Kerala, which is situated in Idukki, right? And we have some other dams also, but major one in Idukki. We have four units, four generators. They're producing around 780 megawatts in Kerala from Idukki alone. So that is hydroelectric generation using the potential of water, right? So that is hydroelectric. Then we have thermal power plants. In thermal power plants we use what I can say, the coal means what? Whenever you are burning coal, then you produce heat, and that heat is getting converted into electrical energy through a process of, like, usually we use steam. Then that steam passes through a turbine rotating, which rotates, and you get the which rotates the generator shaft, getting you power. So that is thermal power plant. There are different types. Then there are nuclear power plants. As I told you, it is using nuclear fission or fusion reaction. Then from there you are getting the power, and that is utilized for generating electrical energy. Then you have wind generators. I think you might have seen wind generators, right? There again, this wind speed is used to rotate these fans, which is connected to a generator shaft, and that way also you can produce power. So then solar power, this wind and solar, they are also known as what? The renewable energy resources, right? So in renewable energy resources and solar power, we discussed about the new scheme in the last lecture. So solar power is, again, you use solar panel, place it, and whenever solar radiation is there, that solar panels, the semiconductor device, it will convert the solar radiation into electrical energy, and you use it. Okay, so that is solar power. Then we have biomass. Even the tides are used for power generation. Like, whenever you are having a tide, again it is what? There is a flow of water, and there is definitely power in it. So we can use that, and that is tidal power generation. And there is something interesting about magneto-hydrodynamic generation also. So these are things we are going to discuss in this first module. Okay, so the main part what we are going to discuss in first module is this generation part. In that, in this particular lecture, we will be looking into hydroelectric generation. But before that, let us see what is the scenario of Indian power system, or how in India we are generating power. Okay. So this is the overall summary of our power system power system generation, you can say. Okay. So in India, the major component of power generation comes from thermal power plants. In that also, it mostly comes from what? The coal-fired power plants. Understood? So that comes around 63% of it, as you can see here. Then The next thing comes from hydro, definitely, right? And in India, this thermal power plants are controlled, the major thermal power plants. Okay, there might be some private sector or by state-owned power plants, but other than that, major power plants are handled by National Thermal Power Corporation (NTPC). Then similarly, for in case of hydro power plants, right, you have got very high headed in the Himalayan rivers, or where even it comes to our rivers in Kerala. So that potential when we use, that comes to around 12% of the total installed capacity, right? So for that also we have a central public sector company which is called as National Hydel Power Corporation, or NHPC. Then for nuclear power, we have another public sector company is called as Nuclear Power Corporation of India Limited, NPCIL. So in nuclear reactor, you might be familiar, right? Even there are so much what I can say what I can say, so much agitations also occurred with nuclear power plants in our near past, right? So nuclear power plants also are there, but that is producing on that is only, the potential is only 6.7 gigawatt, and when it comes to percentage, it is only 2%, you can say. Then the emerging trend is in the renewable energy resources, that we have a very large potential for solar energy as well as wind energy, and we are in the way of utilizing that, so that there is a increment in the last decade in that area. Like now with the wind, solar and bio combined, if you see, wind is what this yellow color, right? Wind, solar and bio, if you combine, it is around what, 25%, right? 10 and 3. So around 20 to 25% of the installed capacity now is from renewable energy resources. So that's an interesting turn. Okay, so and that is going to increase in the coming future. So this is what is our power system generation capacity, and our peak demand occurred in 1920 period is what, 182 gigawatts. So that means what is meant by demand? Like you are generating your power, and like including me and you and the industries around, all the industries and all the shops, everything, right? So these all are consumers, right? So we consume energy, and or we are the demand, right? So we require electric energy, and that is the demand. So there is always a balance between this generation and demand in power system, because compared to some other form of energy, it is not like we start a car, right? Always petrol will be available in the car. You just start it whenever you need, then from that petrol you are able to run it as per your time, right? Whenever you want. So in electrical energy case, it is not like it is produced at a central unit, right? So and every time you switch on a fan or something, then you can say there is an increase in there will be an increase in the generation also. We will discuss in more detail. So that is meant by generation and demand, and whatever demand was available in 2019-20, maximum or the peak demand was 182 gigawatts. So and to get you an idea, right? So this is Indian power system, and it is quite complex. Complex in what sense? Complex in the sense that, think of a system like you have around 6070 buses. Buses means substation, you can say 6070 substation, 2500 more than 2500 transformers, and in that we discussed about voltage levels also in the last class. So just 765 kV lines itself are around what, in 66 numbers. So these all numbers tell you the complexity of our system, okay, and how much big the Indian power system is. So this is what our Indian power system is, and now you can get more details on this Indian power system scenario from Power Grid or MNRE or POSOCO websites. If you are interested, you can go through. It is quite interesting. They have all the data. Now let us get into hydroelectric power station. That is our today's lecture on hydroelectric power. Basically, when you say water, it is all usually regarded as a conventional energy source, because from those many years, conventional, right? From those many years we are using it. Okay, and some people even say that we should add it into renewable energy also. So basically it's a conventional energy source, and what we require is that, as you know, in a hydroelectric power plant means the main part is that we will have a reservoir like I am showing here, and that reservoir we call as what? Dam, right? There have been so many issues with natural activists and all in constructing dam or in constructing more and more hydroelectric power plants and all. Whatever it is, water is always having a huge potential. Okay, so this is our dam. This is our dam, or through a dam what we are doing is that we are getting the water at a particular height. Okay, and whenever you have this height difference, means whenever it is stored inside this reservoir, it is having some potential energy, and once you are allowed once it is allowed to flow through a pipe downwards, then what will happen? Then this potential energy will get converted into kinetic energy, right? And then it is rotating a turbine. Turbine simply means that quite like a water wheel, right? So like you have a circumference like this, and you have got blades like that, and whenever your water is hitting it, then your turbine will start rotating. Okay, so that is the turbine. And normally in a power plant, it will have like it will be a three or four story building, means 3-4 levels will be there. On the, if you go to like Idiki power plant, on the base level you have the turbine section, means that is better, right? Like you have got that much head, or you have got that much elevation difference. How much be the difference in elevation, that much better will be your what I can say, that much better will be your power generation capability, right? So the lower part will be the turbine unit, inside where it is a one whole what I can say level of in the building. So in there you will have turbine, and attached to the turbine shaft in the next floor you will have what? The generator. Generator means what? It is a dynamo, right? It's just similar to a dynamo. Like you have the poles, as well as you have a you have the field winding as well as the stator windings, and whenever as per it works on electromagnetic induction, and you will have your electricity produced in the generator. So when it comes to the penstock, and when it comes to this, and this pipe through which water flows, we call it as what? The penstock. Understood? This is the penstock, the pipe through which your water is flowing down to the turbine, that is called as penstock, and this turbine shaft will be attached to generator. So once your turbine starts rotating, then what will happen? So just with that, as you can see here, once again, whenever your turbine is starting rotating, then this is the picture of this turbine and generator. The down part corresponds to your turbine, like water is entering through one place, and your turbine blades will start rotating, right? And to attach the same shaft you have this generator part. Understood? Just like a dynamo you can say. So this generator shaft is there. Whenever this generator shaft is rotating, on the stator windings you will have electricity generated. Okay, and that will be what? That will be transferred to from remote places to you through what? Through power transmission network. So that is what happens. And on top of that you will also have a place for control. Okay, usually that will be in air conditioned room, and the turbine room is the most noisy place in a power plant, and generator also quite noisy. But in the control you sit there and you control what I can say, all the activities of this power plant. That is what normally happens in a power plant. And once this water is utilized after turbine, what will happen? After turbine, once it is taken out from turbine, it goes to the tail race, or it might be a river, right? Means by this dam we are obstructing the flow of water to the river, constructed a dam, right? So that is what is done usually. And means after our hydroelectric power use, we are really getting it back. Okay, so when some usually nature activists say that you are obstructing the the flow of river, and they are very much worried about it, but we need power for our daily activities as well. So that is about an introduction into hydroelectric power. So basically what you have to understand is this much only, the potential energy of the stored water is getting converted to kinetic energy and it is utilized for rotating the turbine, and that is again used for generating electricity. Okay. So in any generating system, the main parts are this only. What? This turbine and generator. Both are attached to the same shaft, so that whenever your turbine is rotating, then your generator is also rotating, and you get what? The generator means what? A magnet and a coil. So whenever your magnet or coil rotates or your magnetic flux varies, then you have what? This electric, the induced EMF will be on the coil. So that is what we taking out. Okay. So any generator it is, whether it is thermal or hydel or any nuclear, wherever it is, this part is same. The turbine generator set is always the same. Okay. The difference only comes in what is rotating this turbine. Okay. When it is a hydel power plant, it is what is rotating, the water flow is rotating. When it is something else like a thermal power plant, then the steam is causing the rotation. When it is nuclear power plant, again steam, but it is coming from what? It is coming from the fission reaction. So that is the difference. Now let's see what all things are needed. Means just some mathematics here. So basically, for hydel power plant to work, first you need the flow of water, right? Some flow of water should be there. Then to have the water flow, let me say that you should have a difference in the levels of water, as we have seen. Like you have a dam here, or water is coming from here, and your power plant is here. Whatever be the difference in height, that is called as head, right? Means difference in height is called as head. Here you had water. Okay, so based on this height, you have some potential energy in here, and whenever it is coming down, that is getting converted into kinetic energy. So that head we are calling it as H. So basically, the energy available is what? The potential energy, and you know how to write a potential energy. It is given by what? The mg into H, right? Mg is the weight of the water, and H is what? H is the the head, right? So that is what the energy available, the potential energy available, mgh, right? No more explanation. I think you don't need an explanation on that. So what is mass? Mass is or density is what? Density is given by mass by volume, or mass you can write it as what? Density into volume, as it is given here. Then G into H. I am just manipulating it. Then what? Then when really we always say in terms of power. So let us convert it into terms of what? Hydroelectric power, right? We say. So let us quantify it in terms of power. Power means what? Work done per unit time, whichever for which we are having this potential energy, right? So in place of that work, if we place energy, then what? Rho VGH will come, and we are dividing it with the time. So here I am utilizing this V by T part. V by T will become what? That is what we call as the discharge. Discharge means how much water, how much meter cube, or how much volume of water is getting into the turbine per second. Understood? Per second. So that is what we get as the discharge. So our hydroelectric power we can find out using what? Using this rho Q into G into S. That will give us the total hydroelectric power in a in what you can say, in a power plant. But later on we should see, like whenever it is coming through the penstock, there will be losses in the penstock, right? Whenever the water is flowing, there might be some losses in the penstock, and there might be some associated losses inside the turbine. So efficiency of the equipment will come into this, or will get multiplied to this. Other than that, the power, or the whatever be the capacity of the dam or the power plant is based on this relationship. Now, can we construct our hydroelectric power plant anywhere we want? Really, we cannot construct like that, right? Like if some river is flowing some way, we cannot go and construct a dam here. First thing we look upon is that how much quantity of water is available. Understood? How much quantity of water is available means, if it is like we cannot go to like a place where you have a steep hilly area and some river is flowing, and most of the time that river is empty because there is no rain. So you should check how much quantity of the water available you should check. Then another part is that how much of that quantity of water can be economically stored, means whether we can construct a dam and we can economically store water in there. Economically in the sense whether we can construct a dam there and store it inside. So that is these two things need to be considered when you are selecting a site or when you are designing a power plant. So then the next part is what the head of water. Like you have a very nice rain and you have a river flowing, but if you do not have the height, or if it is not a hilly region, then it might not be economical, or it might not be that good to construct a dam there, because head is the main thing when it comes to a dam, right? So means head of water, so that also is dependent. And another part is the catchment area, right? So how much catchment area is there? Like when you construct a dam, yeah, you are obstructing the flow, but whether you are able to store water in a particular area, like you have a dam situated here, and if it is like only this much is your area, and some other place you have a bigger area, then you should go for that higher catchment area, because that is what decides how much water can be stored, right? In a dam you are going to store water so that there is potential energy, and you are converting, you are using for power generation. So that area will depend. Like let me say you have 1 centimeter rain occurring at a place. What? 1 centimeter rain occurring at a place. What is meant by that? This 1 centimeter rain. You might have heard in weather forecast or somewhere, like 1 centimeter, 2 centimeter, 4 centimeter. The biggest that was the biggest happened in a long time. Such news you might be hearing, right? So what is meant by that? 1 centimeter is the what the height occurring. If you know the catchment area is this much, that into 1 centimeter will give you what? That into 1 centimeter will give you the total volume of water. And even out of that water, how much we are getting available? Like once that water come due to rain inside our catchment area, it came inside our catchment area, let us say, but some of it is getting evaporated also, and some you have a rocky surface over there, and some is getting lost through that rock system also. So these all possibilities, or these all understanding we should have while deciding the catchment area. Then another one is the distance of the site from the load center, right? Most of our hydropower stations might be very much remote. So how much far it is from the load center means, again, to consider how much economic it is to construct a dam there and transfer power. Then we have to think about the losses. Then accessibility of the site means, for once you construct a hydel power plant, you need working engineers to work there, right? And you cannot like drop that place should be that much accessible also. Like it should not be an inaccessible place, or where people cannot go and work, right? You cannot construct you might not think about constructing a dam at like Siachen glacier or somewhere, even if there is water, because it is quite hard, like whether it is economical, for operating it also. So that is what is meant by the accessibility of site. So these all things you should be considering. Again, the geological consideration. What is meant by geological consideration? Geological consideration means this much only, like you construct a dam, okay. As I said before, let me say you are not aware of the rock structure in the bottom of the catchment area. Then you have a very high catchment area. Again, due to the nature of the rock, what will happen? Even the water can be lost to the tail race of the river. Even though you have a dam, it might what I can say, there can be a flow of water through the inside, right? So that is geological consideration. There are several such consideration even when it comes to the strength of the dam, and also or even whether it's like earthquakes can happen. All those things will come under that. So these all things we have to consider when we are selecting or constructing a dam. Now let us start classify the hydroelectric power plants. So there are different kinds of classification. One is based on the water flow regulation, means means we will see that what is meant by water flow regulation. One kind is called as runoff river plants, runoff river power plants. Okay, I am sorry, there is no that second F is not there. Okay, just runoff river plant. Okay, you can cut it off everywhere. Runoff river plant. So in runoff river power plants means like you have a very high head and like a hilly area like Himalaya or such very high hilly regions. Nothing in Kerala is an example for that. Mainly there are very good microhydral power plants in the Himalayan ranges. So there you have got a very high head and there is no place to store water, but instead you have got such a steepy hilltop and there is lot so that kinetic energy of water can be directly used. Such river power plants we call as runoff river power plants. Mainly they are microhydral power plants. There, when I say it is runoff river power plants, then frankly there is no need of a dam. Okay, there is no need of a very big dam, the ones you see a NAS dam that you see in Idukki. That is not at all needed. So that then it will become what? It will become economical. So that is the main part. You are able to get more power also, at the same time it is economical also. Then the second one is runoff river power plants with a small storage. Small storage, again same thing. You have got a high head and at the same time you are not able to store to a large extent. So you make a small dam. Then you can use it for power production. So that is another example of the what thing. And then you got the large storage type plants. So Bakranangal, I think the one of the biggest dams in India, right? Bakranangal. So such dams, large storage type dams, where maybe your head is not that high, but you are able to store water to a large extent and it can be used. So such dams are called large storage type dams. Okay, so that is the thing. That is the one type of classification of hydroelectric power plants. Okay, this is the Bakranangal dam that you are seeing. Now, another way of classification is based on the head. On head, you already understood what is meant by the head, right? And based on head, the type of turbine also changes. So, if you take a high head, there are three types. One is high head plant. The first one is high head plant. Mainly, it is used in what? The hilly terrains, where you have, as I already mentioned, you have got a such a large hill in a very hilly terrain like Himalaya. So there what? There our interest is not to store water mainly. The flow of water from a large height, that kinetic energy we are directly using. In order to use that means we are concerned about the velocity, right? When you use a kinetic energy, you are using that high velocity, that impulsive force. So to use that we use what? We use the turbine which is called as impulse turbine. We will see what is meant by that later or how it is working. So this kind of turbines are used in the high head plants, and there we are directly using the velocity of water or the kinetic energy of water due to the large head available. Then you got medium head power plants where we use another kind of turbine which is called as Francis turbine. There, as the name implies what it means that you are not having such a very high head, but it is somewhat lesser. Then you have got low head plants. Again, here your head is comparatively lesser. Okay, head is comparatively lesser, and under such cases you are like what, just if you take out the water and its kinetic energy will not be that bigger, but when you are storing water, then what? Then there is some potential energy, and that pressure of water that can create the enough energy to produce electric power. So there we use a different type of turbine which is called as reaction turbine. Okay, we will see them later. So these are the type of the power plant based on head: high head plants, medium head plants, and the low head plants. And when you come to impulse turbine, it is quite similar to a water wheel. As you can see, there are this cup-shaped blades, right? You have this wheel like this, and there are this cup-shaped blades. And whenever water is flowing, then this thing will start rotating. Okay, so that is so okay. And oh, I'm sorry, it will be rotating in the opposite direction. Okay, my animation is wrong. Don't mind. So whenever this water is falling on this thing, then it will start rotating. As you can see here, mainly you will have a nozzle like this, and your water will come with a very high velocity. Why? Because it is coming from such a huge head. Understood? So that kinetic energy is directly used here, and it is just coming, that force is directly coming. Okay, and your what will happen, this thing will move in the same direction, you can say. So that is what is happening, and it will start rotating. That is what is happening in the turbines. And in a Pelton wheel turbine, this is the image of Pelton wheel turbine here. Okay, this is the image of Pelton wheel turbine, and this turbine is an example. And you have cup-like bed, and it's, here, as I said, here what matters is the kinetic energy, or the velocity of the water is used, you can say, when it comes to a Pelton turbine. Then you have got what, reaction turbine. You can see the size of a turbine here, right? A reaction turbine really looks like what? It looks like quite like a fan, right? Similar to fan also, what is happening here. As you can see here, water will just come and go through this turbine. And just like a fan, whenever water is coming and going through the fan, what will happen? Due to that flow of water, or you have some pressure here, and whenever you are taking it out to this thing, or letting it flow through this, then what, that pressure is utilized, that reaction is utilized, and that is why these turbines are called as reaction turbine. And one such example is Kaplan turbine. Okay, and Francis turbine is a special case, quite like a mix of both, or that we will see afterwards. So these are the different type of turbines when it comes to hydel power plants. So in the next class we will discuss more about hydroelectric power plants. I think you are having a basic understanding on that. So what I want you to do is that you have to write notes on whatever you heard today. Write notes and upload it in Google Classroom under the assignment given with this lecture. Okay, I don't want you to copy down the slide or copy down from others. Just write your understanding. Means it need to be only what you can take. You have a class note. So in the class note, just write whatever you understood today. No need to copy from the slides. I will give you the slides. Okay, no need to copy from others. Just write whatever you understood. Okay. So with that, thank you for your time. We will see in the next lecture again more about the hydroelectric power plants. Thank you.